Okay, let's look at this Leetcode problem. And the problem statement is find all subarrays in a given list of numbers where the product of the elements inside the subarrays is less than k, right? So in this example, k is 100 and this nums is our array, right? So what are the subarrays which contain elements which product is less than 100, right? And the answer is like there are 8 subarrays. 10 itself is less than 100, right? 5 2 6, all of these elements, and 10, and this subarray 10 comma 5 is also uh, a valid answer, right? Because 10 times 5 is 50, which is less than 100, right? Similarly, 5 to 6 is a valid answer, right? Because 5 times 2 is 10, times 6 is 60, which is less than 100, right? So how many such subarrays exist? The answer is 8. Okay, so now let's start solving this. So the way to solve this is we can use the sliding window approach, where let's say our begin pointer and end pointer of the sliding window starts at the first index, right? So let me give an example. So the example in our Leetcode problem was this, right? Input array is 10 5 2 6, k equals to 100. So now what we can do is like I said, with the sliding window approach, we can have two pointers. Let's say begin pointer, let's call them left pointer and right pointer, right? And they both start at 0. And what we can do is we can we can keep moving the right pointer, and in doing so we will create a sliding window, right? For example, if we move the right pointer, so that's the left pointer, this is the right pointer, right? So if we move the right pointer one step forward, then this will be our sliding window. And what we can do is we keep moving the right pointer one step at a time, and make sure that the window that we create doesn't violate our condition. And our condition is that the product in the window should be less than 100, right? Less than k. So, and anytime the rule is violated, we move the left pointer forward and check the condition again. And each time that you have created a valid window after moving to a new right pointer, you create the number of subarrays that is equal to the number of elements in that window, right? For example, let's say the value of k is 200 in our for a hypothetical scenario, right? Then, and let's say your previous window was 10 comma 5, right? After you move one pointer, after your right pointer moves here, how many new sub arrays have you created? You have created a new sub array that contains 2, and that contains 2 comma 5, and that contains 2 comma 5 comma 10, right? So the number of new sub arrays that you create when moving right is equal to the number of elements in that window, and the number of elements in the window is equal to right minus left plus 1, right? So right minus left plus 1 is basically you're counting the you're just taking the distance between the right minus left, the distance between right and left, and you add plus 1, right? Because for example, you have, let's say, two elements in your window, 1 comma 2, right? What's the left pointer would point to some index, right? Let's say 5. right pointer would point to index 6, right? What's the number of elements? That's 6 minus 5, that's 1, plus 1. You add a 1 to get the total number of elements in the window. Okay, so now let's start programming this. We declare the variables that we need. So left starts from 0, right also starts from 0. Let's call our answer as ans answer, starts at 0. This is the thing that we are supposed to return, and we should also keep a running count of product in our window, right? Which starts at 1. Now, so we keep incrementing the right pointer, right? So while right is less than nums dot length, well, right is less than this length, product equals to product into equals to nums right. So this is just a shorthand of saying product equals to product times nums right. We're just finding a product of the, we're just multiplying whatever product we had previously in the window by the new number that's pointed by the right index, right? So while while right is less than nums length, right? And now what we have to do is that while this product is greater than or equal to k, which is the condition that's that violates our subarray that we need, right? While this condition is violated, we keep incrementing the left character, the left pointer, right? So that hopefully we may find another window that contains that is a valid subarray. But so we have already incremented the product by, we have already multiplied the product by the current index, right? So if this situation arises where the product after adding the new element is greater than k, you have to exclude the left element and take the next one, so that maybe you find the correct subarray there, right? So when you include the left element, when you exclude the left element, you product divided by equals to nums left, right? So you divide the product by the whatever number that you wanted to exclude, and you move one step forward, right? You do this as long as the condition is violated, right? So maybe your next window will be the one that we need. So while product, so that's what we did, and the answer will be the size of the window, right? Which is right minus left plus 1. So we increment our answer by the new subarrays that are formed. Yeah, this is it, and we just return the answer. Oh, we forgot to increment the right pointer. That's why we ran into infinite loop over there. Right plus plus. Says wrong answer. Also, when k is 0, we should return 0, but we are returning yeah, so -6, right? So that's just an edge case. So if k is less than 1, we return 0. Less than equal to 1. So even when k equals to 1, that k equals to 1 is also an edge case. Yeah, so it's accepted.